You're listening to the Kielder Observatory podcast. I'm Ian Brannan, and welcome to the episode from February 2022. In this month's episode, really, it's over to you, as we gave you the chance to ask us some questions about whatever you liked in our Ask An Astronomer, which was a live feed on our Facebook page, and lots of people gave us plenty of questions. So you're going to listen back to that episode with myself and Director of Astronomy and Science Communication at Kielder Observatory, Dan Pye, as we work through your questions, but also update you on everything happening at Kielder Observatory this month. And of course, we had to start with the weather, which has dominated many of our lives, but particularly at Kielder Observatory and around the forest. It has caused a bit of disruption. And Dan Pye is with us now. It has been an interesting time, hasn't it, with the wind at Kielder?
It's certainly been weathering. I think that's one thing you could certainly say. Yeah, it can cause major issues. And to be honest, wind is like a new thing for us. I remember in previous years, we always dread this time of year because we think snow is coming and we're going to have to deal with it at some point. And yes, that does inevitably mean closures. So we have to close when it does become a little bit more inclement because the track is unsafe. But this year we've had the new anomaly of wind as well. And wind, although it is windy in Northumberland anyway, this wind has been rather destructive to us, of course. So it's made things a little bit more challenging. Certainly kept us on our toes. But, you know, we're still there. It amazes me that the building withstands the kind of torture that it does and doesn't bobsled down the hillside, which I'm expecting might happen sometime in the future. Who knows? It is perfectly safe. I must add that right now, just in case anybody's worried.
And things are now back open, though. And what are we looking out for in the night sky at this time of year? Because moving into February, obviously, we're starting to notice the evenings getting a little bit lighter. We're getting towards the springtime, of course. What are the things to be looking out for astronomers in the night sky at this time of year?
Well, I mean, there's the usual staples of this time of year, which are things like galaxies. It's a galaxy season, is what we might call it right now. It's moving into that season where we get to see a lot more galaxies within the constellation of Virgo, the big Virgo supercluster that we're part of. We're gazing into that patch of sky right now at night, so we can start to pick out some of our favourite galaxies to look at. Some of the biggest galaxies that we can see in our night sky as well, albeit that they're very far away. And my very favourite galaxy, which is visible at this time of year, of course, the hairy eyebrow galaxy comes into view at this time of year. And that's in the constellation of Virgo as well. But more recently, we've seen a lot more activity surrounding the aurora as well. Of course, our sun appears to be more active at the moment. There was a huge eruption from it the other day, which was stunning to see on some of the space telescopes visuals that they produced. And of course, consequently, some of that sends material our way, which will trigger the northern lights, the aurora borealis. So we get to see that occasionally here in northeast England. And a couple of weeks ago, I saw it from my back garden for the first time, which was unbelievable. I couldn't believe it, and it was a moonlit night as well. But it was still there on the back of the camera. So it's kicking around, and it's always more active when we get towards the equinox as well. So hopefully we'll see a little bit more increase in activity as we creep towards March.
Yeah, because we've been talking about this for a while, that it's a part of a big phase that we go through with the aurora. You get minimum and maximums, and we're not there yet. We're a long way off, really, the very peak of aurora time, as you phrase it, the aurora juice being, being sort of at its most, where we're going to get the best conditions. But that said, probably a bit of a surprise that we've had so much aurora. It's certainly so strong that as we've seen here in the northeast at this time of year.
Yeah, I guess so. When you look at the lovely graphs, who doesn't love a graph? When you look at the graphs, there's an indication that we're getting a real strong increase in solar activity compared to previous cycles. But that can also be almost like a false start, if you like. So we might get a huge amount of activity right now, and then it might start to dissipate, and we might get some longer spotless days on the horizon, and it might be a little bit anticlimactic. But who knows? We can hope that it's going to be a good aurora season as we start to creep in towards the in towards the solar maximum in a couple of years' time. Fingers crossed, I guess. We don't know what's going to happen. Well, you never know with the sun, do you? It's an unpredictable thing, particularly in northeast England.
Well, yeah, there is always that, and yeah, even if the aurora does turn up, there's always the weather to contend with to get through as well. But we try our best. Welcome to everyone who's just joining us. I know that we have actually chosen the time that Boris and Patrick Vallance and Chris Whittier are giving the big announcements at the moment about about the end of restrictions, which was a great time to choose. Dan, yeah, definitely 7 o'clock was the one to go for. But please do, if you are just joining us, leave us a comment in the comment below this post. We're doing Ask An Astronomer, so if you've got any questions that you'd like to ask Dan about space, planets, life in other universes, the aurora, astrophotography, any of those subjects and more, anything to do with space, the night sky. Dan is Director of Astronomy at Kielder Observatory, and he will answer your questions right now. So just pop a post in the comments, just type your question in, and we will work through them. We've talked about the aurora, of course. In our last episode that we did live, we were with Dr. Olivia, who was... I think she probably had a fairly busy Christmas in the end, because she was working on the James Webb Telescope, and that's one of the previous episodes, and she was sort of looking forward to the potential that it might well get into space. Of course, it is now in space. When will we be expecting the first images from this, and what are we going to expect from it? Because a lot of people I know have listened to our episode with Olivia about the James Webb Telescope since we did it, and particularly around Christmas, I think people must have found it. So when are we going to see the first images from the James Webb Telescope, and just how much is it going to blow our minds?
I think it's going to start to come in around about May time, by the looks of things. It's focusing on its first target star right now. I haven't actually checked out what the progress on that is today, but yeah, it's focused on its first star, and it's going to hopefully produce the first kind of images, or the first images that we'll get to see around May time. And these images should they should be absolutely fantastic resolution, incredible resolution, I guess. Well, incredible not resolution, but incredible images that we've never quite seen before of particular objects, because of course the size of mirror that it is, it's getting a lot more light, and because of where it's positioned as well, much less interference. So yeah, I think we'll start to see some really incredible images come through, but stuff that you and I can't physically see with our eyes.
If you had the James Webb Telescope on Earth, it would be powerful enough to take a picture of a bee on the moon. That's how powerful it is. So that's, we're going to see some very deep images of the universe that's going to be like nothing we've ever seen before. And I believe what they're going to do as the first image that they're going to release will be a comparison with one of the great images of Hubble. And so it'll be a side-by-side comparison, and we'll see just how clear we're going to be able to get an image of these various galaxies and so on that Hubble photographed, and then we'll have the same comparable image with the James Webb Telescope. Let's answer some of your questions, because we're here to talk about whatever you want to talk about. Tonight it's Ask An Astronomer. Dan Pye is here, Director of Astronomy at Kielder Observatory. I'm Ian Brannan, and we want to work through your questions. Let's go to Nicole. Hello, Nicole. Nicole asks, what's your preferred type of telescope for planetary, specifically for imaging?
That's a very good question. Hi, Nicole. I think we're going to have to get something which has got a reasonably tight field of view. So I would say a reflecting telescope, something like if you wanted to go with a smaller one, you might want to go with something that's like a Schmidt-Cassegrain of some description. You can get some really, really nice, and not to kind of push any particular brand, but there's some really nice Celestron telescopes. Celestron C8 in particular is the one that I'm thinking of. And it's a brilliant telescope for taking images of planets. And then what you need is a little planetary camera to pop in the back of there, and then point it at your planet and take some images. Planetary imaging is almost like sticking a webcam in the back of a telescope and recording a video, because what it'll do, the software is it searches through the files for the best ones, because the problem with our atmosphere wobbling around is that when we're taking images of planetary objects, it makes them quite distorted and wobbly and weird if we were to just do a long exposure. So instead, we need to get lots of really quick exposures and then take all of the really good ones and make something out of that, if you like. So in short, a reflecting telescope, 6 to 8 inches, something like that might do the job quite nicely to begin with, and a little planetary camera to attach to the back of that.
Okay, thanks for your question there, Nicole. If you would like a question answering, it's an open forum. We're here to answer your questions. Well, Dan certainly is. I can help out on certain things, but Dan is a real expert. Ask an Astronomer, and just post in the comments to this post on Facebook, and that's how you do it. Next one then is from Neil, who says, as we're talking about solar activity, any tips for solar observations? Thinking of setting my scope up to capture the partial eclipse later in the year. How would you go about that then, Dan?
Partial solar eclipse. So you're going to need, you want to filter out lots of light when we're doing this because it can be quite dangerous. But the thing is with the partial solar eclipse, you're still going to need that as well. So, let's just think. See, I'm thinking on the fly here is what's happening. So what I think we should probably consider here is something like a solar filter for whatever telescope you've got. You could have any style of telescope, really, reflecting or refracting telescope. Of course, a refracting telescope means you need a smaller solar filter, but essentially what you need to do is to get some film, which is a specific solar film, and you can make your own out of these, but I would watch a YouTube tutorial on how to do it properly, just in case you don't want to lose a retina or something like that because the sun's bright. So what you would want to do is get some of the solar filter and put it over the top of your telescope lens, and then take your images through that. And what that does is it filters out 99.9% or something ridiculous of the amount of light that we get from the sun, and just makes it safer for you to observe and safer for you to image with as well. So some solar filter paper, solar filter would probably do it, and the partial eclipse, that'll probably do the job with that as well, because it's still going to be quite bright.
Good stuff. Hopefully that answers your question there, Neil. If you'd like a question answering, just type your message in the comments. Simple as that. And come straight through to us, and we will work through them all until you can take no more. David Goldsmith is next. What are the chances of seeing the Aurora Borealis in Northumberland? Well, reasonably
Saw
good.
It last
I
week.
think.
Yeah, reasonably good. Yeah. Saw it last week, and it's kicking around all the time. The thing is with the Aurora is you can never predict when it's going to happen with any great deal of notice. So a few days at best for an assumption that it might be the right conditions in order for Aurora to happen. So what you need to do is just keep an eye on the Aurora by having an app which can tell you about that. So send you a little notification when there might be some Aurora coming. Something such as Aurora Watch UK, that's a good app to use. That'll send you a little ping push notification to tell you that Aurora is imminent. However, that didn't go off the other day when we saw Aurora from here. The only indication that I got that there was some Aurora taking place was from a different website, one called Glendale Sky Aurora. So Glendale Sky is in the places in Scotland. Sorry, I'm drooping, aren't I?
Do your own punchline.
So Glendale Sky Aurora is the place that you need to that I would recommend going to, because that's based on observations, but also based on some really in-depth information as to what the current conditions are like with our magnetic field and the solar wind and all of the other stuff that comes into play when we're talking about the Aurora. So if you go to places like that, you can also set up a notification with them as well, I think, although I've never set one up myself, so I'm not sure how it works. But you can set one up with them, and it's a great place to just go and check to see if anybody's seen it near you. So if you get a notification from another app that says Aurora might be imminent, go to Glendale Sky Aurora and see if anybody else has spotted it near you, and then you know whether to bother to get outside in the cold or stay at home. And Facebook groups are a good place to keep an eye out for information as well.
So that's Glendale Sky, and of course you've got the Aurora Watch app as well in the first instance. But that's a couple of ways. But the Aurora has been around quite a bit, as we were mentioning at the start. Really, it's been visible probably more than you would imagine at this time of year and so on. So always keep your eyes peeled. You never know; it might just make an unexpected appearance. Next one then from Sam Black on Ask An Astronomer is when do you think we will hear more about the developments with Alcyonius? Did I pronounce that right?
I have no idea because I'm not sure what that is.
Okay.
And I'm not ashamed to say.
Okay. We'll come back to that one, shall we? David Fuller is next. If the universe is 13.7 billion years old, how is it we can see that far back as space was very small at that time? Theoretical.
But if space was small, so were we. Is I guess the question at that point. So yeah, I guess it depends what you consider as small, because it would have still been rather large at that point in time. Yes, you could argue that it's getting bigger all of the time, but then the matter of the size of the universe is a matter of perspective, really. It's small to us, but we don't really know how big the universe is. So what scale are you measuring the size of the universe from is the kind of question, I guess, you arrive at that point. But we can see that far back in time because we can see to the point at which the universe became transparent. So we can see the point by which the universe started to emit light, or light was able to pass through the universe. And that's what we can see when we talk about being able to see 13.7 billion years into the past, or 13.8 billion years into the past. We're able to see the point in which these original photons were let loose through the universe. So prior to that, everything would have been so densely compacted that photons couldn't travel through the universe at all. They would just travel, they would emit themselves and then become reabsorbed almost instantaneously. Whereas at this precise moment in time, which was about 380,000 years after the Big Bang, the universe had become sufficiently less dense enough that these little photons of light were able to start traveling around the place. And what we can see is what we call the cosmic microwave background radiation, is that point whereby the universe started to become transparent. And what's really interesting about it is it bears a kind of structure to it. And that structure is a very early imprint of our universe. And that imprint is the reason why everything started to develop structure in the later stages of the universe. So when galaxies started to form, or stars started to form, and really this is something which hopefully the James Webb Space Telescope will tell us a little bit more about, is how did all of those original things get going? Well, James Webb will be able to tell us a little bit more about that. So yeah, in short, I guess the answer to the question is we can see that far back because the light's been traveling for that amount of time from all directions around our horizon. But the matter of size thing is a matter of perspective, and I think a question which is hard to answer because it's a matter of how you look at that, I guess. Hard question.
But as you mentioned there, James Webb, that's another thing that it will tell us, because it will see much further back in time, and pretty much the sort of the echoes of the Big Bang, I think, in ultimately is what they're hoping to find from that. Next question then. This is Ask An Astronomer. It's our Kielder Observatory podcast. This month it's entirely over to you. So if you're not keen on the subject we're talking about, then you can change it by just leaving a comment and ask a question to Dan Pye. Dan is the Director of Astronomy at Kielder Observatory, and he's here to take on your questions as much as he can. Next question then. Andy Brown says, talking about imaging planets, what would you recommend for imaging nebulae and other deeper field objects?
Great question. So actually not too dissimilar kit from what we recommended before. Really, the bigger the telescope for this stuff, then the better, of course. If you can get a wider telescope, you're getting more light in. But you also need a telescope which is reasonably fast as well. So a telescope which is going to be quite quick, good speed telescope. Something like I'm not going to give you any examples on that, actually. We'll just leave that up and leave branding out of it, unless somebody pays us money.
Right, okay. Give a
No,
clue.
but no, just a big reflecting telescope of some description would be quite nice. You're going to need a tracking mount with any of these, by the way. We haven't really touched upon that, but you're going to need a really good quality tracking mount for these as well. And certainly the base level entry on tracking mounts for imaging anything in the night sky is going to be something like the Skywatcher HEQ5 Pro, which is a great mount, and it can take up to maybe an 8-inch reflecting telescope, or bordering on, I push it as far as maybe a 5-inch refracting telescope. And either of those would suit this style of imaging quite well. I think I would prefer a reflecting telescope for things like nebulae and galaxies and such, because you've got a narrower field of view, you've got a bigger optic, so you're getting more light through, and that's ultimately what you want to do, is you want to get more light through to get these really dim objects. And then in this case, there's two routes that you could take here. You could just stick a digital SLR onto the back, and that's a really good, effective way of getting images of galaxies and nebula quick. If you really wanted to push the boat out and go to the next level of learning, then you need to move into what's called CCD imaging, and in which case that becomes a little bit more complicated, and you start to get involved with things like filter wheels and stuff, and taking images for very, very long periods of time. It's not something that I'm massively educated on, to be honest. And what we should have had is Dan Monk here to talk about astro imaging, because I'm starting to notice that there's some real astro imaging questions coming about. So maybe that's the one for a future podcast.
Indeed, let's maybe park that idea for next time. Have a whole special just on astrophotography and really geek out on all that kind of stuff. Thanks for your question there, Andy. One now from Jane. Hi, Jane Mackenzie, who says, "What's happening? What's happening, Dan? What is happening with the magnetic pole at the moment? And what happens when the poles flip, please?"
Oh, that's a good question, isn't it? So the magnetic poles are drifting, as they do normally. That's just a normal thing that happens. There's nothing abnormal that happens there. The magnetic poles do drift, and they have done through the history of the Earth's existence. And we can see that by looking at certain rock formations. In particular in Africa, actually, there was some real good evidence to suggest that the Earth has experienced quite an aggressive shift in its poles in history. So that is a natural occurrence. The poles do drift, and if they were to completely flip, to be honest, I'm not entirely sure if it would have a huge impact on us as humans. I'm trying to think of a scenario. It's a geophysics question, that, which is actually a really good question for somebody who I really wanted to get on as a guest this month, and I wish we had, because they were a geophysicist and they would have been brilliant to talk about the magnetic field and stuff, but unfortunately they weren't available. So I'm not sure what would happen if the poles flip, but I'm going to defer that question to one of my colleagues throughout the next kind of hour and see if we can get an answer on that one.
Okay, we'll work on that, Jane. We do have some great experts coming on the podcast in the coming months. So do look out for these upcoming episodes where these answers might be explored in a bit more detail. Thanks very much for your question, Jane. If you're just joining us, welcome along. If you've just finished the watching Boris and his announcement, we are completely on the wiser as to what he said, but we know that we're on at the same time. So if you've got a question, what we're doing is we're doing Ask An Astronomer. This is Dan Pye with me, who is the Director of Astronomy at Kielder Observatory, and he will be able to at least attempt to answer all of your questions, whatever it is about space and the universe and whatever else you may have for us. Just leave your question in the comments section below this post. Just type in the comments and your question will pop up here and we'll try and answer it for you. Okay, next question is from John Cole, who says, "Hi, I'm visiting on Thursday evening for the very first time. What sort of things have I got to look forward to at this time of year?" Well, first of all, are you there yourself, Dan? Are you there yourself?
Yes, I am on Thursday, actually. Yeah, I am
Well,
at the observatory on Thursday.
there's one thing, John, eh? One thing, you get to meet Dan here, director of astronomy. Himself will be on shift, so you've got that to look forward to.
I'm not sure that that's going to be a highlight, to be honest.
It could be a crowd pleaser. Hopefully not a cloud pleaser.
So, well, this time of year is arguably one of the best times of year to observe. People always say that the springtime, February time is a really great time of year to observe. For me, I disagree with that, but other people agree with that. So we'll go with that. It's the best time of year to observe, and the reason being is because we get the darkest skies at this time of year. But we also get to see some really deep structures which we can't otherwise see at other times of year, in particular those galaxies that I was talking about very briefly earlier on. So this time of year is galaxy season. We get to see some stuff which is incredibly far away. My favorite galaxy, for example, as I keep bleating on about it, the Hairy Eyebrow Galaxy, is 55 million light years away. You can see that quite comfortably with one of our telescopes. That, of course, has to be on a moonless night. Now, I've been on holiday for a week. And because I'm such an experienced science communicator, I don't know what phase the moon's at right now.
Great.
But I'm going to take a guess that it's into its last quarter. But I might be totally wrong. Yeah, I think it's probably into its last quarter because it's new moon on the 2nd of March. So it must be in its last quarter. So it's going to be up later on at night, I think. So you might get a bit of moon as well, maybe. I think Ian's trying to verify that right now, are you? Is that what you're doing?
Yeah, we're currently in waning gibbous at 73.1%.
Yeah, so we're just heading to last quarter.
Third quarter.
Yeah. Cool. Yeah, so maybe a little bit of the moon, and maybe the moon does tend to get in the way of some dimmer structures. The Orion Nebula is out at this time of year. Even with that kind of moon, we could see the Orion Nebula for sure, and that is an absolute spectacle at this time of year. But failing that, any clouds that tend to happen upon us, you'll still have a great night anyway. We'll look after you. We'll make you hot drinks. We'll treat you to a look at our rock collection. It's the best rock collection in the north. Honestly, it is. You'll touch stuff from space. So you leave having touched stuff from billions of years ago. And of course, you'll get to have a nice time with whichever astronomers are on that night as well. And we'll guide you around the observatory and show you all the stuff that we've got hidden away. So either way, you'll have a good night.
You'll certainly have a good time, and I'm sure you'll be back for more, John, after your visit. And of course, the radio telescope as well now is a new addition, and of course, it's quite imposing because it's one of the first things you see when you come up the track and you get right to the top. You see this big satellite dish pointing skywards in one direction or another, and you'll know you've arrived. But there's that as well, and that's a relatively new addition to Kielder Observatory, which we have an entire podcast episode all about, by the way. So if you go back to some of the previous ones, you'll be able to hear more about that. But that, Dan, does give Kielder new opportunities, doesn't it, to learn about the night sky in a different format. It's something that you can do and learn about the night sky and do some imaging in a way when even regardless of the weather. But now you've had that facility for a month or two now. What are the things that you've found with it and that you've learned from it? Now you've got to grips with the new equipment.
We've learned how to break it, or at least I have.
Was not the research we were looking for, but
I think it's anything when you get a new toy, you have to learn how to break it in order to understand how it works. So it did have a momentary period of and not functioning as it should do. But we've fixed that since then, and everything's working fine with it now. This is still very much in its infancy with us, though. We're still learning a lot about it. We're working with Durham University at the moment, and a student there in particular who's looking at a communications package, which she's putting together for us in terms of for our learning as well as science communicators. We need to learn a little bit more about radio astronomy in order to be able to communicate it effectively, because it's quite a complex area of astronomy. It's not the same as looking at an object. You don't get the same from it, and you also learn a little bit more, a little bit different stuff about whatever it is that you're looking at with it as well. So we need to really understand a little bit more about what's happening with what radio astronomy is, and then how we can use that to communicate to the general public. But from a practical point of view, in terms of stuff that we can do with it right now, we can do these observations of objects which are incredibly far away. Such as a star which has died. We can see the remnants of this dead star through clouds, and we can do that any night, really. We can see these objects through clouds because radio signals aren't blocked out by clouds, whereas visible spectrum light is. So it gives us a way of being able to still see something, or at least almost prove that something's there by looking at it in a non-conventional sense. It's a very different way of looking at stuff in the night sky, and we can learn a lot of interesting things about whatever objects it is that we're looking at. But what we need to do is just understand a little bit more about how it works and try and package that all together. So I think the next 3 to 6 months for us is going to be a huge learning experience with this particular piece of kit. And I think we'll probably be in a better position to start talking about it more comfortably come May time.
If you'd like to ask us a question, it is Ask An Astronomer from Kielder Observatory. Dan Pye is Director of Astronomy and is here to answer your questions. Here's an interesting one. This is from Sarah, who says, is every star we see located in the Milky Way, in the night sky?
Oh, that's a really good question. I love that question. Yeah, absolutely, it is. But it depends on if you're talking about individual stars or if you're talking about points of light. And the reason I say that is because you could argue that the Andromeda Galaxy is naked eye visible. And although it's not seen as individual points of light, would you still call that stars inside of the Milky Way galaxy? Well, you wouldn't, because they're outside of the Milky Way galaxy. And actually, I love this question because it reminds me of a story, and it's a Northeast-based story, actually. There's an astronomer through history. It was around in the 1750s, a guy called Thomas Wright, and I bleat on about Thomas Wright so often at the observatory because I think he's such a fascinating chap, and of course a local northeastern astronomer. He came from Bishop Auckland, and he suggested that we were inside of a big island of stars, and when you look up at the night sky, all of the stars that you can see are in our big island, if you like. But there was these fuzzy blobs that he could see with telescopes, which he thought maybe weren't inside the same island that we were. Maybe they were other, as he called them, island universes. And this work went on to inspire the works of Immanuel Kant, of course, one of the most famous philosophers of history. And he wrote some stuff about island universes and stuff. And anyway, it turns out that this guy in the 1700s, Thomas Wright, was absolutely right. These things are inside an island kind of structure, if you like. And the Milky Way is a big island of stars, of about 300, 400 billion stars. And every one that we can see in the night sky is contained within our Milky Way galaxy. But there is other islands of stars, galaxies as we now call them, which are elsewhere in the rest of the universe. But what's interesting is that we didn't know that, or we weren't able to confirm that until less than 100 years ago. So it's only really the last 100 years that we've known that galaxies exist elsewhere in our universe. Prior to that, everything was in the Milky Way, but now we know there's other places as well.
Wow. And with that, though, is that including things we can see with the naked eye? So if people are in their gardens looking at the night sky on a clear night, everything in that way within the Milky Way with the naked eye, or do you need specialist equipment to see those points of light outside of the Milky Way?
Yeah, so everything. The only object which is naked with visible with the naked eye, which is outside of our galaxy, is the Andromeda Galaxy. You could argue if you're in the southern hemisphere, then you've got the Magellanic Clouds, but I guess you would still they're kind of like a supplementary galaxy to the Milky Way. But the Andromeda Galaxy you could see with the naked eye from the Northumberland Dark Sky Park. But that's the only object. Some people say that you can see the Triangulum Galaxy with the naked eye. I've never been able to see the Triangulum Galaxy with the naked eye. But for us in the Northern Hemisphere, Andromeda Galaxy, that's the only thing you can see outside.
We're doing Ask an Astronomer. We have an astronomer. He is Dan Pye, Director of Astronomy at the Kielder Observatory. If you have a question, probably getting towards last orders, but get your question in there now on the list. All you got to do is just pop your question in the comments below here on Facebook, hit send, and it will appear at our end, and we can have a look at your question and try and get you some answers. Next question then is from Kimby Lynch. How do you go about volunteering and learning more?
Oh, so volunteering. Yeah, so volunteering at the observatory. Anybody can get involved volunteering. I originally started as a volunteer back in 2016, and it's the best thing I ever did. It was really just a hobby to go up to the observatory and have a nice time, and then it just became a place where I become shackled in. Anyway, no, it's a great place. Yes, volunteering is a thing that you can do at the observatory. We are a charity. We rely on volunteers to help bolster the events, but also we want to encourage people to learn more. That's exactly what we want to do, and that's exactly what the volunteering program is designed for. It's designed to enable people to learn more about astronomy and physics by coming and volunteering at the observatory. And you can find out more about that and apply on our website, kielderobservatory.org. Fill in the application form, and we'll pay your expenses to come and volunteer at the observatory. Isn't that nice?
There you go. You see, so get volunteering, and you get to go more often. That's for sure. Because in terms of the availability of the sessions, things are very busy, of course, as they always are at Kielder Observatory, aren't they, Dan? And many of the sessions over the coming few months are booked up. I think you're looking at summertime or even beyond. If you're looking to book today for one of the sessions, but there is plenty available over the course of the summer, I think, though, isn't there?
Yeah, there is. There's plenty available over the course of the summer, but up until about May time, I think it is at the moment, May, June time, we are quite full at the moment. But there's always cancellations that come through occasionally, although it may start to get lesser so over the coming months. But yes, always check out on the website, see where the next availability is, but book in nice and early to avoid disappointment, I guess, is definitely the message.
You're watching the Kielder Observatory podcast. You should say we're listening. Today you're watching, and we are answering your questions live. Pop a comment in the post below if you want to ask a question to Dan, Director of Astronomy at Kielder Observatory, about anything. We've covered the aurora, we've covered galaxies, we've covered the James Webb Telescope, we've covered photography gear, we've covered lots. But if there's anything that we haven't covered yet, please do get in touch and just pop your message in the comments and we will cover it. Here's one from Paul Fox. My wife and I are looking forward to visiting you again in March and can't wait. You do get a lot of people coming back for more, which is always a great sign, isn't it? And many times we've interviewed people for this podcast, and they're not first timers. They make and people travel a long way to come as well.
Yeah, they do. They travel across the UK, but they also travel across the world in some cases as well. We had a guy who came to visit us from Malaysia a while ago, and he wanted to do two things when he came to the UK. One of them was to see Manchester United Football Club play football at Old Trafford, which he did. And the other thing was to come to the Kielder Observatory, which he did as well. And he stayed with us for a few nights, and it was brilliant. So people do come from across the world, but more so more regularly. People come from across the country to visit us, and with the hope of course, being able to see things in the night sky. But one thing that I must stress about the experience with the observatory is that if you're interested in astronomy, it is your opportunity to really chat to us about your passion and enthusiasm, and help us bring that enthusiasm out of you as well, because sometimes it might be inclement, there might be clouds, it might be raining, but we still want to talk about astronomy. It's the thing that we love, and we want to share that with you. So we always try and impart that enthusiasm and knowledge onto anybody who comes to the observatory, and give you some of that experience, as we might call it, the Kielder moment, the Kielder experience. Whatever it is that you take away from the event, if you've come to an event and you've taken one thing away, that to me is absolutely a success. That's what we're trying to do, is even if it's just a very simplistic fact, like all of the stars in the night sky are suns. Sometimes that's a revelation for people, and I think that's incredible, that people take that away from us. So it's always about taking something more than just the stargazing away from the observatory as well.
And our sun, compared to some of the stars that you can see, is minute, isn't it? Some of those stars are actually huge, massive, giant things that would really dwarf our sun if they were side by side.
Yeah, our sun's rubbish. Yeah. No, it is a relatively small sun. Is our sun? It's if you got 60 light years away from our sun, it would be very dim to you, which is incredible, because some of the stars that we see in the night sky now are much further away than 60 light years. In fact, my favorite star, somebody on Twitter the other day posted, "What's your favorite star to look at in the night sky?" And everybody's default answers were Betelgeuse. Oh yeah, Betelgeuse, because Coxie talks about it all the time, calls it Beetlejuice and all that stuff. Or Sirius, because it's big and bright, the brightest star in the night sky. Woo, amazing. But actually, what about the interesting ones? Those two, yeah, I guess Betelgeuse is quite interesting. But what about things like the Garnet star? It's a little bit more difficult to find, but it's a beautiful star, a little tiny red star that it appears to us. It's literally just this little tiny faint red light just in the constellation of Cepheus. And it's visible to us all year round as this particular star. But what I love about it is that it's a beautiful red colour through a telescope. And I'm colourblind, and I really struggle with reds and greens and stuff like that. But I can see how vivid this star is, really, really vivid colour. And what I love to consider is that when you see this with the naked eye, it's one of the most distant stars that you can see to begin with. It's 6,500 light years away, which is a long way for a star to be visible with the naked eye. And it's because it's massive. This star, we think, is about 2 billion miles in diameter. Now, when you compare that against our sun is less than 1 million miles in diameter. It's tiny. But even compared to our planet, the sun is 1.3 million times the volume of our planet, and 109 times the diameter of our planet. So it's ginormous is our sun. But to think of this one that's 2 billion miles in diameter, I think that just blows my mind every time I see it. And I see it quite regularly. So I think it's an incredible thing. Yeah, an incredible thing to look at. So yeah, our sun is very, very small. There's much, much bigger ones out there. Ours just happens to be the only one that we know that life exists around right now. But hopefully James Webb will change that.
Yes, well, if our sun was as big as many of the others, then perhaps we wouldn't have life on Earth. So it's fine, just the size it is. You got to say that. What have we got here? One from Sophie. It's Ask An Astronomer. Your questions, just type in the comments below and we will answer them. It's my dream to visit Kielder. This is from Sophie. Hopefully I'll visit someday. When is the best time to come? Well, I think I'd hazard a guess at this, but I'll defer to you.
Well, my favourite time of year is, as I often mention, the end of August to the beginning of September. I think it's a nice time of year to come because you get at this time of this year in particular. I mean, we've got the planets still in view at that time of year. We've also got a little bit more temperature at that time of year. The midge is starting to dissipate as well, which is always an encouraging factor. Get rid of the midge. Nobody likes those. But the Milky Way is coming into full view in all its glory. For us up here in the north, where we kind of miss out on some of the better times of the Milky Way, because it's really June through to September is a really spectacular time of year to see the Milky Way. And it's a great time of year to head south to places like the Canary Islands to go and see it from there. But certainly the September time here in the UK is a beautiful time of year to see the Milky Way stretching above our head. We can start to see deep into the central section down towards the south. And if you come on a night where there's no moon, you've got more of a chance of being able to see all of that structure in its glory as well, of course. So some really interesting things to look at in the night sky: clusters, double stars, individual stars, Milky Way, even a few galaxies visible at that time of year as well. So it's a good comprehensive time of year, I think, to stargaze is September time.
Yeah, September's good. And of course, it's getting darker a little bit earlier there as well, because obviously June, it can be like midnight or beyond before you start to get any kind of proper darkness at Kielder, can't you? Because so far north, and the evenings are lighter anyway. I did a astrophotography session the first time I ever went to Kielder a number of years ago, and it was something like the 18th of June, and it didn't get dark until we're on the way home. But it was a great night, of course. But and you learn the skills. That's the thing. You don't necessarily have to the darkness for that. You learn the skills, and you can take them with you for wherever you want to use them. But certainly, September's a nice mix, nice weather, a little bit warm, and a bit of darkness, and get the clear skies, and you're absolutely laughing. But any time is a good time, though. There's always, clear skies is all you need. So thanks for your question, Sophie, and hopefully see you someday. Here's one from Nick, who simply says, "Wow."
Thanks, Nick.
That was in response to the sun, the chat about the suns and the stars that are way bigger than the sun. So it could have been just a general reaction to your sheer presence. I'm going to have to peer over the top of this one because it's quite a big one.
Oh, look at that. It's very big.
The universe is infinite, apparently. Can you try to explain this and or give us an idea of what you think is beyond the universe, if anything? And Judith says, great job, thanks. I've missed most of this podcast. Can I see it later on some platform? Yes, you can, Judith. Well, I'll tell you this now, and then Dan will give you this deep answer to the universe. But yes, you'll be able to watch it again on Facebook, where obviously you are right now. It will be able to watch that again and again, the full video, probably within a few minutes after it's finished. And we'll be uploading this audio to all the usual podcast places tomorrow. So Apple Podcasts, Spotify, any podcast app you pretty much dare to mention anywhere in the world. It should be on there some point tomorrow, and you can listen to the audio feed of that, and we'll edit out the bits where Dan's camera fell on the floor and all that kind of stuff. If you missed that, certainly worth watching that back.
The raw cuts, I like it. I like that. I mean, I wasn't happy with my answer to the small universe thing either. That still it's bothering me actually a little bit. Is that the fact that the universe was small? How can you see the light? It's kind of sent me into an existential crisis.
That's the only thing with live streams. We can't, usually we spend hours editing ourselves together to make us sound succinct, but we can't do that live. We're sort of coping as well as we can. So Dan, do you have an answer to Judith's question then? What's beyond the universe?
Well, I don't have an answer is the answer to that. And it's not because I don't know the answer. Well, I don't know the answer. Nobody knows the answer to this question. It is a very, very difficult question to answer. But there is some beautiful theories surrounding this whole infinite universe scenario. And some of them are comfortable and some of them are not. And I think that's just a thing that you have to find what you feel more comfortable with this different with this infinite universe scenario. So some people say that there isn't a boundary, because you would disappear off one side of the universe and then you would start appearing from the other side of the universe again, like like Pac-Man rules almost. You disappear off one side and you come back on the other side, kind of thing. Some people say that it could be shaped like an infinity loop of some description. So again, you're just going round on yourself. Some people have suggested it's saddle shaped, or the actual shape, a hyperbolic paraboloid, which I love the word of. It's the shape of a Pringle, essentially. I like to think that the universe is shaped like a Pringle. I'm not sure how that would be, but yeah. But then there's other people who suggest this whole thing around, and it's really funny that you should ask this question, because we were just somebody asked this question just earlier on about bubble universes and multiverses and such like that. And you could say that that we are inside of some particular bubble, and there is something on the outside of that, or there isn't something on the outside of that, because the way that we term the universe as origin, the origin of our universe, is that everything started at that point. Time began, matter was born, everything came to be at that precise moment in time. So to say that something is outside of that isn't a logical question in that sense, because there wasn't anything in existence prior to that. But what some people suggest is that our universe came as a result of some fluctuations in, almost like, if you imagine it like a big sea, a big ocean, and little tiny fluctuations create little bubbles, and those little bubbles expand and create these little universes within them. And ours was maybe one of those little tiny universes within that. See, somebody's trying to phone me on Facebook. That's what happens in live conversations like this. So imagine that sea of rippling bubbles now, and our universe is one of those little bubbles that popped into existence. So you might suggest that you might say that our universe is in a bath of many other universes, bubbles that exist all around the place. And something which Coxey talks about quite a lot, just to talk about Coxey, because I mean, he's got some beautiful ways of explaining things, but he draws on the theory that it may be that our universe is one of the universes where all of the physics came into play that allowed our universe to take shape. There may be a bath or a sea full of all of these bubbles where universes failed. Maybe some of those bubbles popped because they expanded too quickly. Maybe some of them didn't have enough gravity to attract material together to create those initial structures in the universe. And therefore, it's just a bath of nothingness within that bubble. Or maybe some of those crushed themselves because gravity was so large inside those little bubble universes, and the bubble almost imploded on itself. So that's a really good, interesting way of, for me, the most comfortable way of thinking about it is that our universe is almost on this little sea of bubbles that's drifting around the place. And what's outside of that is another question to ask, because then where do you draw the line? What's outside of the universe that's outside of the universe that's outside of the universe? Where does that question end? Again, it comes back to infinite. And I think infinite is the biggest problem, and certainly the biggest problem to mathematicians, because I don't think anybody's comfortable with the thought of infinite. But really, it's a possibility that infinite is just the way that it is, that space continues to expand. And if you try and find the end, it's constantly moving away from you. So that could be the term of infinite in that sense. Who knows?
Who knows? That's the big question. And we talked about in a previous episode the idea of parallel universes as well, didn't we? That there might be another universe B, almost, where there's people living in their own universe, and they have their understanding of their own universe and stars and planets, and there might be a place just like Earth, but it's in a separate, behind a wall almost, in a separate part of space that we can't access. It's just, well, it's mind-blowing, really, isn't it? But we will never probably fully in our lifetimes perhaps understand all the answers to these questions. But space and the universe, I guess we may one day find out the answers to these, but certainly that's the theory.
I think it's a difficulty. I think it's just a difficulty for us as humans to go to kind of understand those concepts, because we obviously only understand our universe based on our experience of it. So that's us getting up on a morning, going to sleep at night, getting older, and then eventually dying. So we assume that that's what happens to the rest of the universe. But actually, that's maybe not the case, because actually the question then becomes, when you die, what happens to you after you've died? Your physical carbon body breaks down, but the energy that you were producing, or the energy that makes up our consciousness almost, that can't cease to exist. Where does that go? Well, that could be repurposed somewhere else in the universe. So is it that we just are stuck on this perpetual loop that's never ending and actually never began in the first place, because it kind of loops back on itself almost? And somebody suggested that a couple of years ago, that the end of our universe as we currently model it, as we're comfortable with modeling it, bears a similar resemblance to how we may assume the universe began. So is it that we are just stuck on this perpetual loop? These are all really philosophical based questions, I think, and really philosophical answers that surround these as well, and really things that keep you up at night.
Certainly so. If you are just joining us, welcome along. We're doing the live Kielder Observatory podcast, and it's Ask An Astronomer. It's really over to you. So we're answering your questions. If you have got a question for us, just pop it in the comments. Dan Pye here to your right, my left. Is our Director of Astronomy at Kielder Observatory, and is answering your questions. So whatever you want to hear about.
That well, I'm not 100% convinced that my answers are always that well.
Yeah, but he's but you're getting answers anyway. That's
We're
the main
giving
thing.
it a go.
Get in touch if you've got any questions. Just pop it in the comments below on Facebook, and click send, and it pops up here, and we can work through them. We've got a couple in the bag. Let's hear from Derek. Hi, Derek. I spent a night in Kielder a couple of years ago in my hammock. Luckily, It was a clear night and without light pollution. You could see everything. Needless to say, I felt a little insignificant. Well, that's very brave of you, sleeping there in a hammock. It must have been in the summer, I would have thought, a little bit warmer. You do get a sense of wonder, don't you? I suppose that's the thing. The night sky is so vast at Kielder. It's so dark. And you do see so many more stars than you would see even in sort of a general rural environment, I suppose.
Yeah, you do. Dark sky parks are, of course, great places to go stargazing, because we're away from that light pollution, and that really is the key for any astronomy or any stargazing. We want to get as far away from light pollution as possible. And places like the Northumberland International Dark Sky Park that we're inside of are places where you can do that. You can comfortably come to those places and know confidently that you're away from those sources of light pollution. And so in Kielder, you could probably see up to about 6,500 stars with the naked eye. And if you consider the amount that's in Andromeda as well, you might want to say up to 1 trillion with the naked eye in Andromeda. But so you can see lots of stars, and I think it's really interesting to consider why we're so interested in that. Why are we so in awe of the night sky and these little tiny points of light that are up there? Is it that we can't get there? Is it that it's unknown? Is it just something that's built into our DNA as humans, that we're adventurers? We want to go and travel to these different places, but with the night sky, we can't travel there so easily. So is it that that's what makes it more beautiful, because you can never just gaze upon it like you can a beach in Bora Bora or something like that? It's a place of sheer wonder. It is the night sky, and it's maybe because we can't get there. I don't know.
Thanks for your question there, Derek. Here's one from Penn, who says, my husband and I visit Kielder in the winter months. I'm going to have to peer over the top of this one again. But can't get to the observatory because we bring our dogs. Do you visit the waterside park to give talks like you do at the observatory, and to help those who are not tech savvy with photography of the night sky? Do you have any outreach like that in the local area?
At the moment, we don't actually, but it is something that we are, of course, always looking towards creating relationships, partnerships with people around the Northumberland Dark Sky Park. We do, of course, have great relationships already, but that doesn't always take us into doing talks in those particular areas. But we're always looking to expand what we do away from the observatory. So it may be that over the next few years, we do end up doing talks at the waterside, or we do end up doing talks at other venues around the Dark Sky Park as well. Or just having, in that case, at the waterside, maybe some facility which enables us to leave some little guides on how to take images of the night sky. And that's something that we're always working on right now as well. I think it's important to mention that right now the observatory, the Kielder Observatory, is going through some of the biggest structural changes and development changes that we've ever gone through. And we have been for the last couple of years, really. And so it's really, although we've been established now for coming up to 14 years, we're still in. We've now reached a point where we're starting to diversify what we do a lot more away from the observatory and look for new opportunities, which takes us down different avenues, and start to really hammer into what our charitable objectives are, which ultimately is to communicate astronomy to anybody who's interested, and even those who aren't interested, we'll force it down your neck. So, it's really aggressive, wasn't it? But yeah, that's so we're always looking at opportunities to do more, is what I'm trying to say from that.
Okay, so watch this space, Pen, but at the moment, no, but that's not to say never. One here from Mark Silk, who says his microphone sounds very expensive. It's always good to get a message from Grandmaster Glitch himself. But there we go. Hi, Mark. Mark is a top voiceover artist, and you will have heard his voice on all sorts of things. Too many to mention. Johnny Bravo, I think, is one of them. Grandmaster Glitch, loads of stuff. Hi, Mark.
Hi, Mark.
It's a bit of a, we should merge this to be the first voiceover / astronomy live chat, and we should just merge the two. And
you do it all in different styles.
Yeah, different voices. Mark Silk asks, his microphone sounds very expensive. Not as expensive as his rates, dear. I
wonder if there's any science in go-jetters, actually. I wonder if there
must be science in go-jetters. They're in space, aren't they? They're in space.
Yeah.
In the unicorn. He's in. What is it? Yeah, you know. Yes. I can't remember. You see, my daughter now, she's 5. She's sort of outgrown it a bit. Your microphone also sounds rather nice, Ian. Oh well, thank you, Mark. Yes, well, we're on. We're on the 416 tonight, Mark, as you ask, and
I've got one of
Dan
those as well.
Dan is on the. There it is. He's got the old. He's got the Remington sort of thing attached to it. Yeah, I've got the old U87 over there as well, as you asked, but it sort of blocks my face on this, so I had to leave it behind. It's a bit more nimble. But yeah, as Mark says, you know, things like Go-Jetters, these kids programs, and even actually, this is going to sound ridiculous, but Peppa Pig. They have got science in them, haven't they? And it is sort of an early way to sort of get kids into science. These programs are really important. I went to see Brian Blessed live a couple of years ago, and he was talking about Peppa Pig, and really the reason that Brian Blessed is in it and plays Grampy Rabbit in Peppa Pig is because of the science element, and he's always doing things to do with adventure and science, and to get kids involved in that kind of stuff, and that was his reason for doing it. He said, I want to do it if it's going to teach kids about science, and so that's why that's my Brian Blessed impression there, and that's the reason he does it is because of that reason, to sort of help bring kids into science and so on. But good point there, Mark. Top star of Go-Jetters there joining us on that would be good, wouldn't it? We should have Grandmaster Glitch answering your questions. And one for the
space questions.
one for the kids. Cheers, Mark. Take care. We'll see you soon. And one here from David Fuller. What are the odds of detecting intelligent life?
Very high. Yeah.
Yes, higher than you'd think. I reckon.
Definitely. I mean, you can do some instant numbers on it if you wanted to. Let's have a think. So, number of stars in the universe. Sorry.
Trillions.
Trillions. Well, I think the estimated number, a comfortable estimated number, will be the number 100 sextillion, which is a 1 with 24 zeros after it. So that's quite a big number. Then you could say, well, okay, so there's that many stars, but how many have got planets going around them? Well, off our current observations, we think that there could be 5 to 6 planets going around each individual star, and that, of course, takes into account things like what a star might have 1 planet going around it, a star might have 20 planets going around it. So 5 to 6 per star. So then you could take that number 100 sextillion, times it by 5 or 6, and end up with an average amount of planets. And then you might say, well, how many of those planets are habitable? And you could say, okay, well, based off our current observations, every 16 in 1,000 that we find is within what we'd call the habitable zone. So that's a place where we sit and Mars sits. It's a place where water can be water. It's warm enough. It's not too cold. It's just in the right place from the sun, essentially. And then you could say, well, that's nice. But actually, in our solar system, we think that there might be life outside of that habitable zone as well, because we think that there's places which maybe resemble the conditions of where we think life may have become established around these regions that we call hydrothermal vents. There's 2 or 3 planets, or 2 or 3 planetary objects, Enceladus, Triton, Europa, in our solar system, which might have these particular things. And if it has those things, is it reasonable to say that there is some kind of microbial life in those places outside of the habitable zone? So then you could take the habitable zone and forget about it and just sit comfortably with the number 100 sextillion with 5 or 6, times that by 5 or 6 planets. And then you could also look at the amount of stars which are red dwarfs, or which are potentially firing out all sorts of really dangerous radiation, and red giants, and stars which would be a little bit lesser hospitable to be around. But I still think you'd end up with a comfortable number of Earth-like planets per galaxy. The difficulty is then, how did life jump from being a rock, essentially, to being a thing that's squidgy and able to replicate itself and become a breathing machine or an energy producing machine of some description? Because I guess that's what we do. We effectively process energy in some particular way. So how likely is it that we find something that's able to do that? But then the question is also, is life as we know it what life is like elsewhere in the universe? So you could do these odds all day long, but I think the numbers always stack up in the favor of, well, yeah, of course there's an opportunity for life to be elsewhere in the universe. And I think anybody who is a betting type person would certainly bet money on it. I certainly would. I wonder what the odds would be actually on that, if you were to go to the bookies. Not that we're encouraging gambling here, by the way. Interesting.
And this is a study from the year 2000, that there are as many as 6 billion Earth-like planets in the Milky Way. And
I think that number's probably increased since then.
Yeah. And this is what the James Webb Telescope is going to tell us more about, because it's going to be able to see some of these planets that we just can't see at the moment. We can't see them through a normal telescope. They're so far away. But we're just talking about actually habitable planets in this galaxy, not in the you might have seen this picture that floats around from time to time on social media of all these galaxies together, and there is an image taken by Hubble, I think it was, and there's hundreds of galaxies in this one image, and each of those is full of trillions of stars. The odds are just so wildly high that, if you were a betting person, you'd be absolutely crazy to bet against the fact that we're going to find life in some form. Any life would be something as it stands. Now, here's the thing. If you are new to the Kielder Observatory podcast, a big welcome, of course. But the first episode we did, if you go to Apple Podcasts and Spotify and type in Kielder Observatory, you will find the feed, and this podcast will end up on there tomorrow at some point. But scroll back to the very first episode. We speak to Professor Wallace Arthur, and he knows all about this stuff. And some of the things that he says about the chance of finding life on other planets and intelligent life or anything like that, it's just mind-blowing. And it's in the first episode that we did of the Kielder Observatory podcast from a year and a half or so ago now. But if you want anything to find out any more about life in other worlds, that first episode with Professor Wallace Arthur is the one to go back to, because he says really within 10 years or less, we will find life, some life. It might just be like a germ or, a single-celled organism would be something at this stage in time. But as we get more and more images coming back from the James Webb Telescope, it is possible we could spot that planet where... Well, and this was the thing that he said. He said that without doubt, in his opinion, and he is an expert in all of this, this is what he does. He knows more about this stuff than most. He's written books on it. He says, without doubt, there is a world more advanced than ours that knows about us, but we don't know about it. Absolutely, he would put his house on it. That there is, we're in that kind of almost like a War of the Worlds situation where there is intelligent life somewhere that is watching us. He says that is absolutely bound to be happening. It's weird and mind-blowing, and as so much of space is, but that's why we love it. And but yeah, check out that episode with Wallace Arthur. I'll check them all out, of course, but check out that one. Jane Thompson has been in touch and says, for anyone who is new to this, would you give us a challenge to be completed by the next podcast? Looking for stars, etc., getting kids involved. Well,
isn't
Jane,
that interesting?
I assume that you may be a new listener, because we have this feature called Pie in the Sky with Dan Pie. And,
which still doesn't have its own theme tune, by the way. And we really need to get someone to do that.
Do you know what? Can I write it down?
Yeah.
Pie in the Sky theme. I'm going to write, honestly, because I keep forgetting. Pie in the Sky theme. There we go. I will get my finest orchestra on the case. Pie in the Sky is a challenge. Now, maybe we should do a junior Pie in the Sky. I think that maybe that Jane has a point there. Maybe we should do something for the kids to look out for in the night sky, because we do it, and it's always a little bit more advanced to give you something to really test yourself if you're an amateur astronomer and you really want to look for something a bit different. So Dan will give us that, and maybe Dan, you could give us something for the kids to look out for at this time of year as well, and they can get in touch and let you know that they've found it, and upload their pictures if they've got any pictures. Perhaps there's an idea. So thanks to Jane for the junior idea. I think that is a good point. Dan, over to you. Pie in the Sky. What we're looking for in the next few weeks, then.
You know what the biggest issue with Pie in the Sky is? That I always forget which things I've actually done.
Well, I will tell you if it's to do with a jellyfish or something like. There's always a jellyfish involved, or some kind of sea creature. So if it's not got a sea creature involved, you're probably all right.
It's probably all right. Yeah.
Yeah.
Okay, so there's something that I love to look at through a telescope, and I think you can see it with a pair of binoculars. I'm just thinking, yeah. I think you could probably get this with a pair of binoculars, albeit that you'd need a moonless night in order to be able to do it, because it is quite a dim object, but it's a beautiful object to look at. It's called M35, and it is a cluster, an open cluster of stars. Beautiful to look at through a telescope. These open clusters, by the way, are remnants of stellar clouds, interstellar clouds, or gas clouds which have formed stars. So this is the stuff that's kind of the stars that are left over from them. And this particular one I like because it's right at the foot of Gemini, the Gemini twins. So when you see the Gemini constellation in the night sky, you can trace it out as being these two stick-like figures from there's two bright stars that make up their heads. It's called Castor and Pollux. That's Pollux with a P. And then you can trace them down. They're lying on their sides like little stick figures holding hands. And one of them has a little foot kicking out. And on the end of that little foot that's kicking out is this little cluster called M35. And it's a really nice little cluster. For the kids, let's have a think, shall we? Okay, kids like shapes, right? That's what we'll do, shall we? So right now, in the sky, there's 3 very bright stars which make up a triangle. We call it the Winter Triangle, and it's made out of Betelgeuse, Procyon, and Sirius. Sirius is the brightest star in our night sky. It is, I mean, mega bright. It's super bright. You'll see it down towards the south-ish right now. And Betelgeuse is just above it, of course, the top left of Orion. It's a big red star, orangey red star. And then across to the left is another very bright star as well called Procyon. And they make this beautiful triangle, and the triangle points towards south. So there's my kids thing to go and find. You've got the Winter Triangle for the kids and M35 for the adults. So yeah.
Okay. Good luck. So let us know how you get on through the course of the next few weeks or so, and we'll be back with another Kielder Observatory podcast in mid-March. A couple of other quick questions. If you've got any questions you want to ask Dan Pye and Ask An Astronomer, now's the time. Just pop it in the comments on Facebook and we'll get to them, but I think we're nearly done. Derek MacArthur, the Goldilocks zone, Earth-sized planets like Kepler 186f. Yeah, that's the kind of thing we're looking out for.
Yeah, been talked about quite a bit this week because it's not too different to Earth. A little bit larger than Earth, in fact, this one. So yeah, it's been interesting place to take a look at. What I think about with places like that, though, is I started to end up in this weird scenario whereby I start to think about, well, what's the gravity like on there? Because it's a little bit bigger, so it'd be heavier on that world. And also, because it's bigger, does that mean time is a little bit different there? And then I start to disappear down this strange kind of almost. I always end up with these real existential crises around time and the way that time is experienced elsewhere around the universe, because there's no universal clock. It doesn't tick uniformly across the universe, does time? Because, of course, the laws of special relativity and such mean that when you get closer to an object of greater mass, the time appears to go slower. So the surface of the sun experiences time slower than it does on Earth. And that starts to really mess me up, that. So, yeah, interesting. Don't know why I went on that tangent there. That was just a random little tangent for you.
It's good to go on safari every now and again.
Stripe of time.
And a question from Simon, who says, what would you like the James Webb Telescope to look at first?
I'd like it to prove the theory that it can see a bee at the distance of the moon. No, I don't.
A bee on the moon. If you're just listening, that was right at the start, and it's one of the things that just sort of give a scale, I suppose, of how powerful the James Webb Telescope is. They reckon it can see a bee on the moon if it was on Earth. If they do put it up there and the first thing to come back is a picture of a massive bee, I think certainly Dan would be delighted. But what would you like it to see first?
I would like it to see... it's a good question, because there's a few different things that particularly excite me about this telescope. I would really like it to take a look at a really interesting place like Kepler 186f, to have a look at the atmosphere, the planetary atmosphere of that. Tell us where the planetary Sorry, Panish. You see that when live, you get live burps as well, like that. So Kepler 186 F, the atmosphere, what's that made of? It might be quite interesting to understand that. But from a visual perspective, of course, I want to see what the hairy eyebrow galaxy looks like through the James Webb Space Telescope. Is it going to reveal some really interesting stuff inside? I would imagine it just reveals lots of stars, but it will be interesting.
Okay, there we go. Thanks very much for all of your questions this evening. It's been great to be able to come and answer them for you, of course. And we will do it again very, very soon. Sometimes we do the podcast live like this, and other times we pre-record it, which sometimes, as you may well think, is probably for the best. But you can listen to the previous episodes on any podcast app. So if you've got Apple Podcasts, Spotify, Google Podcasts, any of the other podcast apps that you care to mention, it should be on there. And all of the episodes from the past are available now. The previous one to this was from January, and we were talking about tracking satellites and space junk, which is a new project that Kielder Observatory is involved with, which is helping to keep an eye on all the stuff that's floating around in orbit above planet Earth. We've got an episode all about the James Webb Telescope with Dr. Olivia Jones, who is one of the team involved in that project. And obviously that was before it launched, but still there's some information in there which still obviously is fine now, because now that it's launched, you can listen to it with different ears and see the sort of things it can do. We've got an episode about the new Spider telescope, the new radio telescope at Kielder Observatory, and an episode with Dr. Natalie Starkey, who talks about volcanoes of the solar system and how volcanic activity is a great sign that there could be life on the planets where we find volcanoes. Because
great episode.
Yeah, she's got loads and stuff about the moon as well, and how the moon used to be covered in lava and used to be a big volcanic being in the sky, and it was like basically a ball of fire at one point itself, and also about Earth, because we don't actually know where all the water came from. That's one of the great mysteries of space and science. So she talks all about that. Loads more episodes as well. And I say that one, the one that people do seem to go back to, and maybe it's because we keep going on about it, is the one with Professor Wallace Arthur right at the very start. October 2020 it was, and he was talking all about life on other planets and how that search is going to pan out and all that kind of stuff. So if you want to know more about that, then certainly listen to that episode. And of course, to find out more about everything that's happening at Kielder Observatory, onto the Kielder Observatory website, kielderobservatory.org, and you will find all the info you need about all the upcoming sessions. You can book on to any of them that are available, and find out all you need to know about those sessions, what you need to bring, how you get there, all the rest of it. And of course, for regular updates, follow the social media platforms, which you're clearly doing, to see this on Facebook, but also on Twitter and on Instagram, sharing photos and videos of anything that there is to share with you when we see the aurora and all that kind of thing. And of course, particularly on Facebook, any late availability with cancellations of sessions, of sessions, of course, if the weather's bad, but cancellations of people who've got tickets who can no longer attend, and you might be able to nip in there if you're able to get up there at short notice. So that's pretty much it. Any other business, Dan?
I don't think so. I think it's probably worth just tantling the taste buds for future episodes as well. We do have people planned in, albeit that these people haven't planned in their dates to record with us. We do have people who are planned in the future, such as solar physicists, people from incredibly high up positions within other places who deal with space quite heavily. Some celebrities on the go as well. Who doesn't love a celebrity on a podcast? I'm going to leave that very open to any celebrity, which could be completely interpreted by a particular individual as being a celebrity, even if they just know them particularly well. So yes. It could be anybody, but it is a good few celebrities that we've got to interview as well coming up over the next 12 months. Hopefully, I think the podcast will change in a way that is good. Maybe we'll do them all this way. Maybe we'll do them in person.
Well, yes, that's the next big step, isn't it? That's the next big step. And maybe Boris's announcement, I mean, Boris going head-to-head with the Kielder Observatory podcast, I think, was a very brave decision by him there to take us on at that time and stealing the audience away from him. But yes, in person, and maybe we could do, it's not within the realms of possibility. We have talked about doing it in person with actual people in an audience as well. And some of the guests, I mean, this will be if we get some really big guests that we're kind of working on, get them and you, it could be a great night out. So that's the sort of thing we're working on, making it more interactive and live. And if we get the people that we're aiming at, you've got to aim for the stars and you might hit the moon, is a very astronomically based phrase. But yeah, if we get who we're hoping to get, then yeah, you're going to be impressed. Let me tell you, not as impressed as myself and Dan would be, but it's certainly going to be good. So thank you very much for joining us on this live version of the podcast, and even if you're watching it not live and the rerun, thanks very much for joining us. Find out all that info you need if you want to get any further info about anything to do with Kielder Observatory, kielderobservatory.org, and we will be back with you next month. Keep an eye out for details of the next episode on the social media channels. Have a great rest of your evening and happy stargazing. Bye-bye.
Woo! Thanks, everyone.